Hello, good afternoon, everyone. I am Smaya from Ireland. I'm here to present this work. It's titled Cognitive Digital Twin of a Factory Floor with AI-Enhanced 5G Network. I say a little bit about my background. I am a lecturer at Technological University Dublin, and most of my research are looking at signal processing and wireless communication systems. But since I started my role as a lecturer in robotic and automation, I always feel motivated to combine wireless communication and robotic, and this particular work is a very good aspect of that combination. We all know that digital twins are becoming more and more popular nowadays, particularly when we are looking at automations and remote controlling of what's happening, particularly on a factory floor, for example. So we want to see what's happening, and I often tell my students that we want to have as realistic as possible user interface in a way that we can manipulate, modify, and understand what's happening on the floor. Mainly because we want to keep eye on everything in terms of response, in terms of efficiency, also avoiding any hazardous, dangerous things that can happen on the floor. So there are many aspects that are particularly very important. One thing that becomes very critical is how the data is sent and received, and the latency and time delay between the actions to be taken, and for example switches and sensors and things that should communicate with motors and vice versa. So the time between them, managing them, is very important. So let's say what we have done. I don't know how to click to go next. Okay, now the animation is working. Alright, so the idea was to combine PLC. If you have never heard of this word, it's programmable logic control system. It's a little bit more robust than microcontrollers. If you want to compare them to microcontrollers or computers, they have a wide range of applications. The one that I teach in university is from Allen Bradley brand. There are many different brands depending on the range, the price range and application range. You can find different types of them. They are very applicable in many industries. Most of the time when we are looking at conveyor belts and lots of processes that can be done on the conveyor belt, we are looking at PLC that is controlling and putting them all together. So here in my slide, I'm trying to illustrate that how AI and smartness can help creating digital twin as close as possible to the realistic process that is happening on the floor, and the role of 5G O-RAN network. Someone might ask me, why did you consider 5G? There are many other types of communications. In many industries, they don't even need wireless communication. Everything is wired up, so why you're looking at that particular one? And my answer for that would be, I'm looking at benefits that 5G, particularly 5G O-RAN, can bring on the table. So I'm looking at very low latency, very nice, reliable connectivity, and also the smartness and intelligence that can add to the whole system. So these are very popular on their own, but they can also benefit digital twin and industrial automation. The reason is that physical process often can be stored locally or can be transferred wirelessly or wirely to a processor, and often what happens is that remotely the process is being monitored, and this monitoring is very crucial to have synchronized and stable connectivity to the factory floor, let's say. So with all the benefits that ORAN particularly brings on the table, there are still things that can go wrong. So we did a little bit of a study. We looked at the latency performance and we compared some of the techniques that are popular within this application. So I'm calling the table 2 that from my paper here. So I'm looking at, okay, what can be done that turns the whole system to a little bit more smarter version, and the control system can be done in more smart way. Sorry for my language, I used dump pipe there, but what I mean is that I want things to be able to diagnose themselves before human interaction. So the control can be done in a way that we not only monitor the data flow, we also look at the quality of that connection and whether we can compensate things and diagnose things before happening. So here we have I have one of the findings. So I looked at telemetry latency of the PLC and I compared them together, and looks like if we do manage to put together this cognitive scheduling strategy, we can achieve very good performance by optimizing the latency. I have more results. One of them is looking at how we can remove the long tail delay. That is something that is annoying industrial applications, especially when it comes to safety, because we don't want the error to be persistent. We want to remove it as soon as possible and be able to restart the whole system if something goes wrong. I also have the stability analysis in my lower figure, and you can see that the mathematical formula of Lipomov is helping to define the safety envelope and ensuring that factory operates within the guaranteed stable boundaries and it doesn't exceed that boundary. Then I also have fidelity tracking on my top figure. As you can see, I have a Monte Carlo stability analysis that I have done, and you can see that within the samples the delay is being managed. Then I looked at the robustness of that system, how robust we are managing the system. So the Monte Carlo testing was looking at how AI can increase that probability of stability. Here also we are looking at based on increase in samples, what happens to that stability. So thank you very much. I really like to take this study to further stage, and I really like opportunity to test it out with actual hardware. We are well equipped with industrial PLC testbeds. However, I am planning to purchase some ORAN radio from a local company called Benetel. If I manage to receive funds to do that purchase in the future, I'm going to look into testing it with actual hardware. The presentation was looking at mainly simulations, but in the future I'm hoping to be able to implement it based on hardware or hire some PhD students to do that for me. Thank you very much. I'm happy to connect with all of you. You can scan the QR code here or you can search my name up, and I'm happy to collaborate. Thank you. Bye-bye.